All right, so we are in geometry. Today's date is Wednesday, May 1st, 2019. All right, so I lost my voice yesterday from yelling too much, which means this is about as loud as I'm going to be able to get. Everyone, because I just yell at everyone. So today is completing the square, which is funny because to complete the square, that's what you need to know for a circle lesson that we already did. So this should be review. But normally this is taught in Algebra 1, right, Sam? It's really hard to talk over people when my voice hurts so much. So let's review going forwards with the box method. Box method is a way to multiply binomials. So I need two volunteers, one volunteer to just set this up. Who can set up x plus 7 times x plus 7 with this box method? Do you remember where those terms go? Yeah, Leo. Yep. There it is. Thank you, Leo. And you can turn in your participation card. Yes, let's get those marbles out as well. All right, and now I need someone to actually follow through with Leo's setup. She did, yeah. Her handful is slightly bigger than yours. Not that it's a competition, but. All right, I need one volunteer. Go through this with me. India.
The top left is going to be x squared. The top right is going to be 7x. The bottom left is going to be 7x. And then the bottom right is going to be 49.
49. Thank you. Thank you, India. I can get your card now, too. All right. Jaden, off your phone, please. Otherwise, I have to take it. It's so close. All right, and then our final step for doing the box method is to actually add everything. And this is kind of a key point. These diagonals right here will be like terms. And not only will they be like terms, but when these two terms are the same term, these two terms are the same term. So I guess I technically needed 3 volunteers instead of 2, but I need one more volunteer. Can someone add up the inner part of this box? Can someone add x squared to 7x to 7x to 49 and simplify?
I don't have my card.
Oh, that's weird. Did they get handed back yesterday? That's Algebra 2. Yeah, you want to go for it then?
Sure.
All right. Colby, just go for the participation.
14x.
Yeah, so first start with x squared.
X squared plus 14x plus 49.
All right, everyone write this down. X squared plus 14x plus 49.
Do you have a paper clip?
You probably want like one of these. Even bigger than that.
These ripped, and I can't put them back in my binder.
If you need an even bigger one than that, I have like a mega one, but I only have 2 of them. So.
It's fine.
Yeah, all right. Thank you, Colby. Oh, that's right. It was on your desk. All right. So this is what we're going to do. This process of using the box method. So completing the squares, doing the box method, but today we're going backwards. Jaden, what did I just say? Try again.
2 is distracting you. Can you move them?
Sorry, Mr.
If either of you two are going to distract either one of you, both of you are going to move to this horseshoe desk.
He just doesn't talk.
All right, someone else. What did Mr. Sendell just say?
Go back.
Thank you, Leo. XP, marbles. We're going backwards with this method. So that means instead of starting here, we're going to end here. Instead of ending here, we're going to start here and then go backwards. All right, so let's say that I started with this problem, x squared plus 14x plus 49. The first step is to fill in this gray box with what we know. And then we're going to do, and then there's a kind of a, how do I say this? There's one thing that's kind of particular about step 1, which is divide x term by 2. By 2. What I mean by that is this is the x term. This is the x squared term. This is the constant term. So I'm talking about this term right here, 14x. This 14x was divided by 2 here and here. Kind of separated equally into equal parts. The reason that you do it equally and not unequally is because this needs to be a square. This side and this side need to be the same length, which means that this 7 and this 7 need to be the same length. These 7s have to match. So when you're completing the square, on that first step, number 1, make sure that you're dividing 14 by 2. So 14x by 2, you get 7x and 7x equaling the bottom left and the top right. Okay, step 2. Find this one you've already seen completing the square, so what do we do next? Right now we only have the inside of this box. What do we find for that box next? It starts with an S. Anyone want to take a guess? It's a 4-letter word, but plural, so 5 letters. Not a good enough hint. Find the sides. Find the sides of the box. So once we find the inside of the box, then we need to find the outside, or the sides of the box. So I'm going to pause there, and I don't want to do step 3 and step 4 before you really understand step 1 and 2. So I'm going to go down here to example number 1, and I'm going to do step 1 and step 2. So everyone draw a box. Your box can be slightly longer than it is tall, that's okay. And then after you draw your box, you're going to draw lines that extend outside of the box. So for example, this line is going to extend outside of the box. This line is also going to extend outside of the box. That will help us distinguish between terms that are on the sides of the box. All right, let's see if someone can do step 1 for me. I have x squared and a negative 14x. Leo, go for it. Ooh, careful. So I'm just going to do the inside of the box right here. So I'm not going to deal with the sides yet. What do I put right here? It is indeed x squared. And then this is the hard part. What goes on these 2 diagonal boxes? It is, yeah. So it's half of negative 14x. Careful. Careful again. There it is. Negative 7x on both of them. Thank you, Leo. All right. He got a little bit of help from, Aurelio's not here because he's in the other system. I saw Sam that was helping also. Oh man, Aurelio's getting up there. Helping others. All right, I just did step 1. Now we need to do, Leo did step 1. Now I need someone else to do step 2. Raise your hand, Aurelio. Yeah, Aurelio.
Positive 49x.
Oh my gosh, you skipped all the way down to step number 3,
really?
Which we haven't done yet, but yeah, that is going to be 49. But can you find the sides of this for me? What should go right here, Aurelio?
The x is on top?
X and X, and what about right here and here? Here and here. What times X is, ooh, careful, 7, not 7, but a, there it is. Thank you, Aurelio.
Better give me another one.
Oh yeah, that's right.
He's telling you what to do.
He's up to 4. All right.
I appreciate it.
And now I'm on to step number 3, which Aurelio actually did for us because he's seen completing the square before, which is find the number that completes the square. Completes the square. I can't spell. There we go. And I'm going to pause right here before I actually do step 3 on example 1. Right here we have a square, but it's missing a piece. These 3 pieces are what we are given. We are given x squared minus 14x. There's our x squared. There's our minus 14x. We have everything for the square except for this missing piece. By finding that missing piece and putting it here, you're actually adding something to it, and we are completing the square by adding it to the square. So now we're going to do that. Another quiet raised hand. What is the number that completes the square? What is the number that goes in this box? What is -7 times -7? Quiet raised hand. Let's go with Caroline. 49. Caroline. And I can get your card now. Don't know where I'm having such difficulty. There it is. And there's the answer. The question was just asking, what is the missing constant term? The answer was, the missing constant term is 49. So we'll write down 49 and then box it. All right, so obviously this is a kind of long and tedious process, but there are shortcuts. You should discover the shortcuts for yourself. If you discover those shortcuts, you are telling me, Mr. Sindel, I understand this so well that I don't need to do all of the math. That shows me that you have really high conceptual understanding. All right. So the final piece, number 4, we're going to see in example number 2. And it's usually one of the hardest things about completing the square. And it's making sure that the equation or function, whatever I decide to give you, this one is going to be an equation because it has an equal sign with terms on each side. Example number 3 on the back is a function because it has this f of x, or it could have a g of x. So whether I give you a function or whether I give you an equation, you need to make sure that that function is balanced. Balanced is the word you're looking for. And that is a tricky step. I'll show you how to do that at the very end of example number 2. All right, so I need to complete the square, and I'm going to pause here also to explain why. Why are we completing the square? The answer is we need to be able to solve for x. I have too many x's here. I have an x squared and an x. I only know how to solve for x. I don't know how to solve for x squared. I could square root it, but then I'll have a square root of x that I'll have to deal with. So the strategy here is to complete the square. If I have x plus something squared, by completing the square, is equal to some random thing, I can square root both sides, get rid of the square, and now I just have a linear equation, x plus like 5 or something. And I can solve. It's just a linear equation. So it's a way to transform something that is quadratic to something that is a line. Lines are really easy to deal with. Even in higher levels of math, even in my 3rd year of college, this was the strategy we took. We had these really curvy things, we didn't know how to calculate them, so we found methods that turned it into a line, and then we could solve them. It's the same idea here. So I'm going to complete the square. What I want everyone to do right now is box all the x terms, x squared and x. Anywhere where you see an x, that's the thing that we're going to complete the square with. This plus 3, we're going to have to deal with him later. But for now, let's only pay attention to x squared minus 6x. Again, make your box. Technically, this should be a square, but we'll call it a box. All right, I need a volunteer to help me out to do step 1. I'm looking for people that still have a card that needs to get in. Ellery.
X squared in the upper left, and then you're going to put -3 to the right and -3 down.
You're really close. -3
X.
x. There it is.
Do you want me to finish it?
Oh no, that's perfect. That's step 1. Thank you, Ellery. I need someone else to do step 2. Again, I'm looking for people that still have their cards. I know that Beverly had her card up and I wasn't able to call on her. You want to try it now? Go for it.
It's going to be X on top of here, and X and -3.
Yeah, thank you, Beverly. Beverly just did step 2 for us. I need someone to do step 3 for us, which is finding that constant term, that number that completes the square. Oscar. It's 9. I'm going to circle that 9 because that 9 is kind of important. That 9 isn't in my equation yet. Again, all of this stuff in yellow right now has been given to me in this record. That's orange. Orange, okay. Be nice to be colorblind teacher. All this stuff in orange has been given to us. This 9 did not exist. I am now adding something new to the equation. If I'm adding something new, what do we have to do to make sure that it's balanced on both sides?
I thought it was
I'll repeat the question.
Wait, what color does that look like?
I thought it was
It's not yellow,
I guess it's
Jason.
orange. Again, I need to balance the equation. I'm adding 9 to this side in order to complete the square, but now I have an imbalance. So what do I also need to do to balance the equation? If I'm adding 9 to the left, I also need to add 9 to the right. Exactly.
What other colors can
I mix up quite a few colors, unfortunately. It's not fun.
Wait, isn't like red, brown, or something too?
Our mini tangent here. So colorblindness is commonly misunderstood to just see black and white. If you're a full spectrum colorblindness, you can only see black and white. My colorblindness is a misnomer. It doesn't mean I'm colorblind. It means I have color confusion. I confuse 2 different colors or 3 different colors, like grays, reds, and browns. I will always mix them up if they're really close to each other. Blues and purples, I'll mix those up. Yellows and oranges, I'll mix those up. Reds and greens, I will mix those up. I just mix up my colors.
Between red and orange?
Sometimes it depends on how close they're together. If they're really far apart on the spectrum, I can usually tell them apart. Red and green is the most common form of color blindness. And again, you should think in your head of color blindness as color confusion.
Oh, it's green.
So this is this is a really important point. So the reason that we have standardized stoplights where you have colors in a certain order is because of color blindness. Every state now has the same order. But as we saw in Mammoth just like last week, they have that random sign in the village that just has random lights flashing. I didn't know what they meant, and they're like, the red lights are flashing. Well, is that red or yellow? And I went and I almost ran over someone, but there wasn't a standardized color, so I didn't know what was going on. I didn't know if it was red or yellow. Like,
Wait, so is your colorblindness like you can't see the shade red, or you just mix it?
I just mix them up. Yeah, think of color blindness as color confusion. I just mix up colors. All right.
So if you're like, you gotta yell at the one. Sorry, I'm colorblind.
Wait, Mr.
Epiphany.
What color is this?
Wait.
I'm pretty sure it's orange.
Wait, Mr. Snow, have you
pineapples.
gotten those glasses where they like?
I've heard of them, but no, I've never tried them.
My uncle got those because he can't see like the shade red, and they're so.
Okay. So back to our math.
Sorry.
Back to our math. We have now added 9 to the right-hand side. Here I go. I'm about to rewrite this equation. I'm rewriting this equation. It's now x squared minus 6x. I haven't done anything new. It's still x squared minus 6x. Here is the new number. The new number is 9. I'm adding 9. Here's the old number that I didn't care about, plus 3. Again, I have the original. It's really hard to talk over you guys because my voice hurts so much today.
Sorry.
I have the same numbers here in blue, x squared and minus 6x, x squared and minus 6x. This 3 is also from the original left-hand side. The thing that
Sorry. No, it's not my dojo point.
Sam, you were doing it too, but at least you stopped. I don't know what to do with this. Off task, sure.
Oh, okay, I thought you were taking notes.
Okay, what I've done to this side of the equation is I've added this 9. I now need to balance the equation. So India, with your quiet raised hand, I'm going to give you, what should I put on the other right
Oh, I think
side?
I know what it is. I think
You
it's
should put 9 because you've had 9.
Thanks there. Exactly.
Did you raise your hand?
Positive 9. She did raise her hand, but people spoke over her last time, so I wanted to give her another chance.
I'm sorry, India.
Yeah, we should try to assume that the default is a quiet raised hand unless I say shout it out or I do like the symbol for like, let's hear what you have. All right, so what we've done here is kind of cool.
Wait, let's just ask a question.
There's a question.
How do you buy your clothes if you don't know what color?
All right, another tangent, but it's a good question because for a long time before I met my wife, I had really bad taste in clothes. She picks out outfits and I memorize them and I use them. So I know from now on, if I ever do gray pants, I know that they're gray because they have a little rip in them. If I ever do gray pants, I have to do a blue top. If I ever do blue pants, I have the choice between a white top or a gray top.
But then, do you personally like?
If you've noticed my clothing for the past 3 years,
Yeah,
those are the only 3 color combinations I've ever taken.
Do you have 3 pairs of pants?
I actually only have, I have 4, but
You only have 4 pairs of pants?
I don't have a lot of clothes. My wife has tons of, I'm simple. I don't need many pairs of clothes. It's just going to confuse me.
So what do you do when you go to parties?
When I go to parties,
He's like,
I have very simple choices. Colorblindness is hard, guys.
Wait, then how many? Do you have more shirts then?
I have approximately 7 shirts.
What?
I was
I
gonna
have like
got
20
I'm
shirts.
surprised that you guys are surprised because I feel like that's normal.
Wait,
No?
I think I have like
How much pairs of socks do you have?
I have quite a few. I think
you have
I think I have 2 weeks worth of socks. I have between 10 and 12.
Alright.
What about shoes?
I have 2 pairs of shoes.
actually.
Okay, well,
What
one
size are you?
okay, I have 2 pairs of dress shoes. Shoes that you'll see me wear around school. If there's ever a lazy day where I get to wear tennis shoes, then I have 1 pair of tennis shoes also.
What size are you in those?
13 on everything.
13.
All right.
Stop.
Coming back again. That was a good question, Jaden, because it was interesting. But we're gonna come back from this tangent and talk about completing the square.
I feel like you would look good in like white Converse.
I mean, if I buy my Converse,
Like, oh yeah.
what we've done here in these parentheses, can you write these parentheses in your notes as well? These parentheses is everything that's in this square. Again, this square had the x squared. There's the x squared. This negative 6x, this negative 6x, and that 9. Everything that I'm putting in the parentheses here is a square, which means this is a square. It means 2 things. Like geometrically, it's a square, but algebraically, it's also raised to the power of 2. It's a square, which means, and here's a cool little trick: take the side of the square, take the side of the square, and that thing squared. That's literally what it means to be a square. So this thing that I just wrote in parentheses here is now x minus 3 quantity squared. I have changed my parentheses. This is a square. This is also a square. They're the same square, and the way to get that square is looking at the side of the square. The side was x minus 3. Look, x minus 3. That's how you can convert this square to this square, and that's what you're going to be doing on the homework tonight. How to convert here to here. But I still have this plus 3. Let's get rid of that, because I said that I don't have any plus 3. Get rid of that. Subtract the 3 on both sides. I'm going to be left with a 6 out here, a minus 3 in here. I'm done. I've solved it. Minus 3 goes here, 6 goes here. I'm done. Again, I'll show you what that looks like. Question?
Wait, so the 9 is part of the square then?
So adding 9 is completing the square, but I have to do it to both sides, yes.
Wait, okay, but then, like, because you in the parentheses you have x squared minus 6x plus 9, and that goes to x minus 3 squared, and I see that has the x squared in the 6x, but where's the 9?
So if I were to write this out, x minus 3 times x minus 3,
I am lost.
Sorry.
If-
I think I'd be that more confused.
if I do x minus 3 squared, or x minus 3 times x minus 3, what I'm really doing is I'm doing
Okay,
x minus 3 times x minus 3. And
So
I
the
have to
negative 3 is both the 9 and the 6.
Yeah.
That's cool. Okay.
So
Yeah, I don't know.
Why do you have to do that? Can't you just skip over to the x minus 3, the power of 2 plus 3 equals 9?
Which step are you seeing now?
Yeah,
Just
what
take
even
the side
happens
of the
if
box.
Oh no, because you still have to find 9 because you're on the other side of the equal.
Yeah, so I
Like
think
in this part, can't you just skip all this and then go to here, from here to here, plus 3 equals 9?
as long as you know that this side was 9, because we didn't know that it was 9. So as long as, I mean, yeah, you're thinking ahead of how to skip steps, and you're right. You can skip the step as long, Oscar, as you complete the square by adding 9 to both sides. So add 9, and then yeah, you can basically skip all the steps and you know you're going to be left with this. So you're right, yes, you can skip steps as long as you know what you're doing from here to get to here, and that you complete the square. Completing the square and adding this 9 to both sides is that key step that allows you to actually get to this form. So as long as you add 9 to both sides and then get rid of that extra stuff that we didn't need, then you're good. So again, I'm going to subtract. Are you okay, brother?
What?
Are you okay?
Yes, I'm
You're going to subtract 3 to both sides, and I'm finally left with the form that I'm looking for, which was x minus 3 quantity squared is equal to 6. Again, that is the form that I was looking at. This form is x plus a negative 3, so I'll write this in red to make it stand out. X minus 3 is equal to 6. That is the answer that I was trying to look for, Oscar. All right, keep asking me questions. I love when you guys ask me questions. It means that you really understand what's going on.
Yeah.
Even if it's, you're asking because you're
Literally just ruined
confused.
This whole math thing, dude.
Let's try another example. Maybe it will be cleared up by a different example. This is I shouldn't say harder. It's a different example, but it's still completing the square. This is a harder example because I no longer have two sides. F of x is the same thing as saying y equals. This is a y equals something that you could graph. The problem with this is I'm not allowed to touch the left. That has to remain y equals, because otherwise it doesn't make sense to graph it. So I can't touch the left, but somehow I'm still going to have to balance the equation after I complete the square. So I'll show you how to do that. So again, anything that has an x in it, x squared or x, box it. That's the thing that we're going to complete. I'm going to complete the square, x squared plus 6x. Let's go ahead and make our general rectangle, our box. This is our third iteration of completing the square. Can someone do step 1? I only see one hand raised. There should be a ton of hand raised by now because everyone knows how to do this, hopefully. How do we do step 1? Beverly.
You need x squared on the top left. 3x.
Perfect. Yeah, Beverly set up step 1. She distributed all of this x's into our square. Thank you, Beverly. Step 2. Who's got it? I need to find the sides. Who can find those sides? I see 3 hands. We got some fast hands already. Who else can do this? 4, 5. Oscar, go for it.
You had 3 on the, or you had x right there.
So x.
X on 3 and 3.
Perfect. Thank you, Oscar. And finally, I need to do step number 3. I need to actually complete the square. Brian. 9, yeah. And this 9 is important. I'm going to circle it. This 9 wasn't in this rectangle that I made. I need to now add that 9. So I'm about to do that. Thank you, Brian. So here we go. I'm going to rewrite f of x is equal to x squared plus 6x, and I'm going to leave some room to add the 9 right here, and I'm going to say plus 90. I just rewrote the function, but I gave some room to know that I'm going to add 9. All I did was rewrite the function. But as Brian told us, to complete the square, we need to add 9, but we can't add it to both sides. So I'm going to add 9 right here. But I have to also get rid of that 9. So I'm going to add 9, and I'm going to subtract 9 over here. Adding 9 and subtracting 9 is the same thing as adding 0. You're allowed to add 0, that's fine. So I'm going to add 9 here. I'm going to subtract 9 here. Now both sides are still balanced. I'm going to add 9 and subtract 9. Again, my perfect square is everything inside these parentheses. My perfect square, or everything in this square, is inside these parentheses. X squared is x squared. 3x and 3x make 6x. 9 makes 9. Everything right here is also inside of the rectangle. We nod our heads. This is a perfect square. Okay, can someone tell me what that perfect square looks like? This perfect square, I'm going to rewrite this, f of x is going to look like something quantity squared. What goes on the inside? Ellery. There it is. X plus 3. How did you get that?
That's what the side.
Yeah, just take the side. Perfect. Thank you. And I still have that garbage stuff out here on the right-hand side. Can someone do that really quickly for me? Quiet raise hand. Easy XP. The easiest of the day. Colby. Plus 81. And that's our answer. It's almost easier than the last one. So this inside is x plus 3, and then on the outside is 81.
Can you do that when the other side of the equation is 0? Well, no, because then you're saying that it's 0.
I didn't understand the question. Can you do that when the other side is 0?
Never mind.
Don't even ask you.
Never mind, I figured it out.
Okay.
I'm sorry.
All right. And I know that this is one of the most confusing parts of the lesson, so I added this for you guys as well. How to balance the functions, or how to balance the equations. How do you know whether to add and subtract on one side or add to both sides? Well, if you have only terms on one side, that means you're on a function like example number 3. So if you aren't sure what I'm talking about, this is like example 3. What did we do? What did we do with that constant? What did we do with that 9? Ellery?
You add it and subtract the constant.
Exactly. We added and subtracted to that one side. And I guess I should have underlined this, to that one side. So if it's a function, if the terms are only on one side, then you can only deal with that one side, so add and subtract from that one side. But if you do have access to both sides, it's normally like that algebra 1, like you just add things to both sides. So then just add to both sides. Both sides should be underlined here. If you do have an equation where you have terms on both sides, then you are allowed to add to both sides. All right. My fist of 5 at the end of the lesson is going to be, how well do you think you can solve completing the square problems on your own? After the notes, how confident are you that you can complete square problems on your own? 5 is, I'm going to ace it. This is going to be awesome. 4 is, I'm probably going to be pretty good. 2 or 3 is, I'll probably need some help. We'll see what's going on. So I see 2, 4, 5, 3, 3, 5, 5, 3, 3, 4. Jaden choose at a 4. Okay. 3. Cool. And that's the end of the lesson. Are there any questions before we end?
So let's
No questions.